Good morning, Miss. My name is Chadini, and my teammate is Ongkaki, Lim Fo Xiang, and Chong Men Yao. And our project title is Smart Traffic Light Monitoring System. The background of Smart Traffic Light Monitoring System will include the first camera and sensor and the AI to gather real-time traffic data and prevent the traffic congestion. And it is designed to monitor traffic flow, identify safety hazard, optimize traffic signal, and provide real-time information to driver. And it is used to improve the traffic flow, reduce the congestion, and also increase the safety of the driver. In the future of transportation management, it will be the Victor rule. Next, I will pass to Lim Fo Xiang.
Good morning. My name is Lim Fo Xiang. Now I will present about the history of smart traffic light system. In the early 2000s, the traffic light system were developed variety of different technologies to gather and analyze traffic data in real time. Some systems use cameras and sensors to detect traffic flow and congestions, while others rely on GPS data from vehicle or mobile phones to track traffic patterns. In 2004, the automatic traffic surveillance and control, the AirTag system, was developed by the city of Los Angeles, which is used to camera and sensor to monitor traffic flow and adjust traffic signal in real time. The system was successful in reducing traffic congestions and improving traffic flow in the city. After 2004 onwards, there is other numerous smart traffic light systems have been developed, incorporating advanced technologies such as machine learning and artificial intelligence to improve their effectiveness. These systems are designed to not only monitor traffic flow and congestion, but also to adapt the changing traffic pattern and weather condition and provide the real-time information to drivers. Next. Now I will present about the problem statement. The first problem is that the traditional traffic light system does not provide real-time traffic situation reports to users. Traffic users are unaware of the congestions traffic as they are failed to be notified of which area are experiencing traffic congestions. The worst case, drivers are forced to get stuck in traffic jams, which further aggravate traffic congestions. Next problem is lack of adaptability of traditional traffic light system. Despite of the actual traffic condition, the traditional traffic light will only operate through a fixed cycle at a fixed time. Fixed timing for a signal changes might cause a high traffic volume in one direction. And the last problem is increased risk of accident due to inadequate time to respond to an accident on the route ahead. In many cases, the driver may not be able to react quickly to an accident and decelerate or stop their vehicle before colliding with other vehicle, as the driver has not been acknowledged about the crash earlier. Next, so the objective of our assignment is aimed to detect and identify the number of cars on the road. The camera capture image of traffic and the system analyze them. It will control and modify the traffic signal timing based on the traffic condition and the number of vehicles for each time. The second objective is to predict traffic jams and reduce traffic congestions. The smart traffic light system predicts the traffic through real-time data analysis. The user management will be notified of the expected traffic condition by using the Amazon SNS feature. And the last objective is to detect an accident which directly reduce the likelihood of collision and accident risk. A vehicle accident detector is able to detect an accident and inform the driver through an email to alert the driver. A vehicle accident detector could optimize traffic flow as an instant notification sent to the driver through emails. Now I will pass back to Chatani.
Comparison of cloud technology, and the difference between three of them is Amazon is pay-as-you-go model support multiple protocol, and Azure is transaction and batch processing, and Google Cloud is flexible pricing model support real-time streaming. And for the cloud-based image and video analysis, AWS is facial recognition and object detection, and Azure is advanced OCR capability, and Google Cloud is flexible pricing model support multiple image format. For the cloud-based IoT platform, Amazon is advanced device management capability, and Azure is bi-directional communication and device pairing, and Google Cloud is offer advanced analytics support a wide range of device.
Now I will explain about the flow of the proposed architecture diagram in detail to illustrate how various system components interact with each other to achieve the desired functionality. First and foremost, the traffic light sensor and traffic CCTV camera will collect the raw data, which is the captured image of the traffic condition, and then upload it to the AWS IoT core through the network. The raw data will then be routed to the Amazon S3 bucket according to the previously configured rules and stored as an object in the bucket. When new data is pushed into the Amazon S3 bucket, the AWS Lambda function will be triggered. The AWS Lambda will obtain the object data from the S3 bucket and process it according to the code. The Lambda function will upload the object to Amazon Recognitions to identify the presence of a vehicle and analyze the number of vehicles on the route. Afterwards, all those traffic data is returned to another Lambda function to proceed with other features. The obtained data will be extracted, loaded, and transformed in the second Lambda function. The progress traffic data will be stored in the S3 bucket, and the system will notify the subscriber via Amazon SNS about the location, time, status, and presence of vehicle accident. On the other hand, the process data will also be stored in DynamoDB. The AWS AppSync will create a RESTful API for retrieving the data from DynamoDB, and the AWS CLI use the curl command to retrieve the data from the API and provide result to the management. Management was be able to monitor the traffic light by sending an instruction to the IoT core, and then the IoT core will pass the instruction to the traffic light. In tandem, AWS data pipeline will routinely export data from Amazon DynamoDB to the Amazon S3 bucket. The AWS QuickSight access the exported traffic data from S3 bucket to visualize the processed traffic data to management. Next, now we will be showing the demonstrations.
First of all, we will use the Node-RED to simulate or act like a traffic light and also the CCTV. And the Node-RED will capture the real-time data and send to the IoT code. And here we click the subscribe. And here we click here. And the IoT code will receive the message from the Node-RED, and the data will store into the S3 here. And now I will pass to my teammate Lin Xiang.
Now I will explain about the Amazon S3 bucket. So here I created the 3 bucket which will be used, which is the traffic image bucket, info, and also the data computer. The traffic image bucket is basically store the image from sending from the Node-RED. So the traffic info bucket is also sending from the Node-RED, which is contain the traffic light informations. Then the data computer will be used in later. This will storing the data exported from the data pipeline, then it will use in the QuickSight. So for the first Lambda function, which is called record Lambda, so the function here is basically to perform the Amazon recognitions and to detect how many cars in the traffic route, the status of the sensor, the traffic time, and also the car condition, whether it's accident or no accident. After that, it will pass all the message to invoke another function, which is here. Then another function is called the text file.txt. So the text file.txt will also collect all the location, the sensor, the detector, which is from the device, the traffic device. Then it will send the SNS to alert the user management, and also store it into the DynamoDB. Then here is the part to upload the data for backup in S3, which is the data computed. After that, this is our Amazon SNS. This is our subscribe topic. So we have 2 teammates that has been subscribed from this subscription, so we will be able to receive the SNS. So after that, the DynamoDB part, this is our created DynamoDB, which will be used. So the first table is traffic data. Then we can see that we really have successfully received all the data sent from Node-RED, and we can view the data. So after that, we will set up the data pipeline, schedule run every 1 hour, which we can see that this is successfully created. It is healthy. Then it will run the pipeline, and in the last, we will configure the quick sign. Here we will click the new analyze and then new data and select the S3 so that this we will give a name. And then here we will paste the data computed, the manifest file. The manifest file will be pasted here. Then we can select copy. We can copy the S3 URI and paste it here. After that, we have connected. We can start to edit and preview our data set. Then on the dashboard side, we have also successfully created a dashboard for the management to visualize the data. So now I will pass back to Chajani for the part.
First of all, after you create an app scene, you will get an API key, which is here. And you just need to click this, and you will retrieve the data from the DynamoDB and use the curve command to retrieve the data from the API key. Here are the data from the DynamoDB, which is the timestamp, the condition, the details, the duration, the file image, and the location. Here we will use the Node-RED to modify as a traffic light, and we use the IoT core to monitor to manage the traffic light. And we just need to select east or west or south node and press the publish, and here we will receive the message each route green light change to 20 seconds. That's all of my presentation.
So as from here, I have subscribed the email. So now I will test the Node-RED to send the data. So we can see that here we have successfully the data and all the information in this format. So that's all for our demonstration. Thank you.